everyone. We're going to find the area of the region bounded by the given curve y equals x cubed minus x. And a line passing through the origin is perpendicular to the tangent at the origin to the curve. So let's unpack this. Basically, we need to kind of sketch this graph, and I want to look at my zeros. So basically, if I take my y equals x cubed minus x, I can write this as y equals, and factor out of x, and you're going to get x squared minus 1. And that's going to equal x times x minus 1 times x plus 1. Also, if I differentiate my y, so y prime, I'm just going to take this one. This is going to be 3x squared minus 1. For this one, when x is 0, we're going to get our y prime is negative 1. All right, so that means your slope to the tangent line is negative 1. So the equation of the tangent line at the origin is going to be y minus 0 equals negative 1 times x minus 0. So that's going to be y equals negative x. Also, the slope of the normal line, therefore, is just going to be 1. And if you do the same thing with the equation here, you're going to get y equals x. So basically, that is the equation of the perpendicular line, which is the normal line. All right. The intersection points are at, let's see. The intersection points we're going to set are two things together. So y equals x to y equals x cubed minus x. So that means we're going to set x cubed minus x equals x. Therefore, we're going to get x cubed minus 2x equals 0. Therefore, we have x. If you factor out of x, you get x squared minus 2 equals 0. Therefore, since we have that, our intersection points are going to be 0, x equals negative square root of 2, and x equals square root of 2. Because this could be also expanded minus square root of 2, x plus square root of 2 equals 0. Okay, now that we have all that information, let's just sketch a graph. So basically, for this, we have our intersection points, or for this graph here, our x-intercepts are at 0, when you set this to 0, 1, and negative 1. It's also a cube, so it's going to go like this. Come up here somewhere. It's going to come back down to this and back up. So that's kind of what that is with the cubic function. Your end behavior always starts, if it's positive, in quadrant 3 and it ends in quadrant 1. We also have this line, the perpendicular to the tangent, which is y equals x. So that is this line here. All right. So the area shaded region that's going to be bounded by that is this right here. And the only thing we need to mark basically is this is going to be negative square root of 2, which we got here. We already have the 0. And this right here is going to be square root of 2. Now, this is symmetric to the origin. So basically, I can use the symmetry fact and multiply this by 2 and just look at this side of the shaded region and then multiply it by 2 to get this side. I know the graphs don't look the same, but I can multiply it by 2. So I'm going to go from 0 to square root of 2. Also, you take your upper bound. So the upper bound was y equals x to the shaded region, and you subtract the lower bound. All right, and that one is minus x cubed minus x dx. Now I'm going to simplify that, and then we can integrate. So let's do that. This is going to give me the integral of 2 times 0 to square root of 2. And then we're going to have negative x cubed plus 2x dx. All right, so let's integrate, and we're going to get 2. This piece is going to be negative 1 divided by 4, x to the power of 4. And this one's just going to be, this term is going to be x squared. And we're evaluating this from 0 to square root of 2. Basically, we only need to look at this because the 0 is going to zero that out. So basically, we're going to get 2. And when you substitute, let's just substitute it in. Square root of 2 to the power of 4 plus square root of 2 squared. All right. This is going to give you 2. This piece here is going to give you negative 1. This is going to give you plus 2. So this is going to end up being 2 times 1, which equals 2. So that is your area. Thank you. Have a nice day. Bye-bye.